In this video, let's take a look at translating sine and cosine. So transformations of sine and cosine are very much related to the transformations we've already learned about in Math 3. So we have the amplitude out front, that's our A value. In other units, we've called that the vertical stretch or compression, and it really works the same way with sine and cosine. We just call that amplitude. B is our frequency, so that's going to be a new one we'll take a look at. Vertical shift is still in the same place it's always been, so that's the D value that's outside the grouping symbol. And then the horizontal shift, like the left or right shift, is still that C that's in the grouping symbol. So notice like those two are very familiar. Our A value still works really like it used to. The new guy on the block is the frequency. So let's take a look at a few simple notes that'll help us figure these out. So the absolute value of A, notice, is your amplitude. So you don't include a positive or negative with that, you just pick out the number. The period is equal to 2 pi divided by B, which is that value that'll be in front of the X in that grouping symbol, or behind the sign, you might see a number right there. That's what we'll pick out for that. If you have plus C, it shifts it to the left, and if you have minus C, it shifts it to the right. If you have positive D, it goes up, and negative D, it goes down. So like those are very similar to the ones that we have seen before. Now let's just take a look at a few examples. So in this first example, it just gives us the function and asks us to pick out amplitude and period. So let's see, did they use any particular color? They had yellow. I'm just going to use blue to pick out amplitude. So amplitude is the absolute value of that number out front, which would just be 2. The period is always 2 pi divided by B, so I'm going to write that down. And B is whatever's right behind the sign and in front of the X. So I just see a 4 right there. So that's going to be 2 pi divided by 4, which we could just reduce a little bit and divide 2 and 4 both by 2, and we would get pi over 2. And usually you just leave that in radians. You don't need to convert that to degrees. All right, let's look at another one. Number 2, the amplitude goes with that number that's our A value. Take the absolute value of it, that would just be 1/3. Period is 2 pi divided by B, and B is this number right here that's between like the cosine or the sine and your X. So I see I've got 2 pi this time, so I've got to put 2 pi over 2 pi, because B in this case is 2 pi. Well, that just equals 1. So you can just leave it that way. Don't put a pi with it because those canceled out. All right, let's take a look at number 3. 3 gives us a graph. So a graph would tell us this, I can tell, is the midline of the graph because that's halfway between the very top and the very bottom. So amplitude would be the height between the midline and the top of the graph. So let's draw that. And then it would also be from the midline to the bottom, so those should be equivalent. So I see I've got 1, 2, 3, looks like our amplitude is 4. And that's why we don't include a positive or negative, because it's a distance from that midline to the top of the graph or the bottom of the graph. I'm going to highlight the midline. The period of the graph, when you're looking at a graph, you can pick out like how long does it take for a full cycle to occur? So I see from 0, that's a good starting point to look at. I can see that this graph looks like a sine graph, and it took to 4 pi before it finished one full cycle. So this period would be 4 pi, because that's how long it took for one cycle to occur. All right, let's look at another example of a graph. So this one asks for amplitude again. So going from the midline, which looks like it's still right there at 0, we can pick out the amplitude. I'm gonna go right here, that looks like a good spot, or right there, either one. So the amplitude looks like we have 1, 2.5, 1, 2.5, so it looks like 2.5. So we could say 2.5, or 5 halves might be written because that's equivalent to 2.5. And then let's look at the period of the graph. So the period would be from where it starts. I just like to start at 0 when I can because it's an easy starting point to judge how far you go. So let's go from 0 and see how long it takes. So it looks like a cosine graph this time. And it took until we got to 0.5 pi before it finished one full cycle of cosine. So let's put 0.5 pi. So by looking at a graph, you can just estimate how long, or like figure out how long, not estimate, it takes for one cycle to occur. Now let's just try a few more examples of finding the amplitude and period of these functions. So amplitude is quick and easy. Usually people can pick that out very easily because that's just the absolute value of A, which was 6. So that would just be 6. For the second one, it would just be the absolute value of 3, which is just 3. And for the third one, it would be the absolute value of 1/4, which is just 1/4. So let's pick out the period for those three. So the period is always 2 pi divided by B. So B in this case is just a 1. There's nothing else right there. So I'm going to write B equals 1 for this one. So 2 pi divided by 1 would just mean that this one has a period of 2 pi. All right, number 2 has a pi right there between cosine and the x, so B would equal pi. So we would say the period is 2 pi divided by pi. The pi's would cancel out and leave us with 2. All right, and let's look at one more. In this case, the B would equal 3, so we would say the period would be 2 pi divided by 3, and you can just leave it like that. You don't have to reduce it or rewrite it as a decimal. Okay, so that's it for some notes on translating sine and cosine.